Hey guys, it's Debbie, and I do not have my microphone. I'm on my way to the gym to work out, but I really want to share this information with you. If you are curious about getting a metabolism test, VO2 max test, zone 2 test, sometimes the information we get doesn't really make sense. And I always like to understand why. Why does that happen? What does that mean? What do I do with this information? My job, I feel my purpose is to help explain what the data is for you and how you can use it. So here's a rabbit hole on my website. What the heck is VT1 and VT2? And then we'll dive into some other concepts. Now you can head to debbiepotts.net, look under my blog to find all this information. Of course, coaching services and my metabolism testing, how to get ready for that, is here, as well as my About Debbie, what I do and why. Now, here are some key definitions. Let's review real quick. I like to understand VT1 gets thrown around a lot and doesn't really share with what that even means. Ventilatory threshold 1. What is it? It is the point during exercise when the ventilation starts to increase compared to the oxygen consumption. So we start to see this change in carbon dioxide and oxygen. So the accumulation of carbon dioxide, CO2, oxygen is O2, in blood as lactate production increases. So you'll hear about Peter Attia always talks about this, testing your lactate, which I think is not really convenient for most people. Blood lactate increases at VT1. This is what Peter Attia suggests: buying your own lactate testing test where your zone 2 is, but it doesn't really tell us exactly what fuel source, fat, carbs you're burning. I'd rather you do a metabolism test, $200, $300, to get these tests done somewhere near you, or have a group and I'll come out to you, or come to San Diego. Come to Del Mar and visit the beach after we pass. We'll go walk on the beach. So VT1, the accumulation of carbon dioxide. The lactate level starts to increase, requiring increased ventilation to expel carbon dioxide. At VT1, the body shifts from primarily using fat as a fuel source that we identify in zone 2 to increasingly using carbohydrates. When I do the metabolism testing, I use the portable equipment Pinoy. I'll show you this graph. I'm looking at this red line on here. They just changed this, easier to see. Your heart rate. Fat is this golden color, and then the carbohydrates. What I'm looking for to determine your zone 2, I could do lactate as well, but I don't need to. I see your fat and carbs burning. So you really don't need to do both. If you are doing a metabolic test measuring your fat and carb usage, there's no point, in my opinion, and what I've been taught. Now, where we see this increase of carbohydrates would be that purple line. And this is kind of spread out, but we could break it down even more. We'll see the fat carbohydrate where they start to break up. Now, this person's really good at burning fat. I've been testing him every 3 months for a year, and really good results from his training and fueling. Now, if we pull down here, you can see the purple starts to go higher than the gold around this rate. So we draw up, what is this heart rate? 144. You can see it's kind of right around here. You start to see a shift. 148. You can see the fat. So about here, 144. Below that would be his zone 2. And then the bottom of zone 2 is your peak fat burning. So all through here. Now, let's go back to this definition. VT1, accumulation carbon dioxide as the blood lactate increases because we were required to expel more carbon dioxide. At VT1, the body shifts from using fat, as I just showed you, to using more carbohydrates. Fuel sources, primary fat, increasing carbohydrates, we just saw. What happens with your breathing frequency? As we look at BF, breathing frequency, and we can match that with your 5 heart rate zones we can identify from the raw data. Now, breathing frequency increases and the breathing rate, carbon dioxide starts to go higher. And then we'll see that correlate with your respiratory exchange ratio, or RER, also called RQ. And we can see the fuel source switching there. Now, what's VT2? So VT2 used to be called the anaerobic threshold, lactate threshold. Occurs at a higher intensity of exercise than VT1, represents a point where lactate accumulates rapidly in the blood. And the acidity, I'll go over in a bit. This is kind of old thinking. We say it's the lactate that's causing the fatigue, but it's the acid changes in your blood. And the increased breathing rate, the body attempts to clear excess carbon dioxide, not the lactate. Remember, that's recycled and used as a fuel source, alternative fuel source. It's the acidity of our blood. But VT2, mostly carbohydrates, quick energy is needed. So as we get higher intensity, we need to have more carbohydrates are being burned as fuel source, not eat carbohydrates necessarily, but that will help for performance gains, as we've talked many times about sprint and HIIT training, tempo work. You're burning more carbs. And so that's why you looking to improve performance, you may need to not eat carbs all day long, is just timing your carbs in and around the workout, pre-workout, post, to refuel for next time. Then you can go back to more of your carnivore meat-based diet, if that's your choice, or paleo or whatever you're doing. So you can see this person's not burning much fat. And then up here near his max, there's not really any fat, 171. His peak heart rate was 180. Really worked hard. Now, fuel source, yeah, no fat being burned, we're burning carbs. So if this person's doing a zone 5 workout, they need to make sure they're having the right fuel source on board. And that's where we will talk next about lumen and how to use lumen to determine your fuel source. If I'm going to do that zone 5 or zone 4 workout, I want the lumen to be showing them a 3, 4, or 5, even a 5 when I'm doing that high intensity. Okay, so let's go back to definitions. Peak VO2. Okay, so what is that? I like to say peak because a lot of people don't reach their max unless they're just type AAA driven person, usually athletes. If I'm trying to market to more people just to do this test because it's beneficial for the aging process to improve longevity, as we want to know the higher VO2, the better we are at aging process, right? As well as muscle health. So VO2 peak is the max rate of oxygen consumption during incremental exercise. The highest amount of oxygen the body can utilize during intense exercise. VO2 peak is often used with VO2 max. VO2 peak may be slightly lower if the athlete does not reach their absolute maximum. So I usually think there's a little bit something in the tank, unless they have done this test before, they might know how to push past that level. Now, fuel sources, obviously carbohydrates, more efficient for fuel, high intensity says quick. Breathing frequency is going to be at your max. So demand for oxygen is you need to expel that carbon dioxide faster. So your breathing frequency will be higher. All right, so fuel switches during exercise as intensity increases. The body's preferred fuel source shifts. So low intensity, we call zone 1, and zone 2 is primary fat. When we get around that VT1, we're switching into more of zone 3. And then we hit zone 4 and zone 5 as the intensity increases and carbs become dominant fuel source. So let's go back to the raw data screen of a test that I did on someone. So you can see the gold is the fat, the purple is carbohydrate usage, and you can see that changes. Now we can also look at this breathing frequencies on the top part. We can add in here BF, carbon dioxide, where's BF? Breathing frequency, and I can track that. Maybe we take out these guys, and then we're looking at fat carb usage. So we can geek out here. Okay, so then we can see heart rate too, I should put in there. All right. And we're going to go spread that out. All right, and we can see the heart rate spread. We need different colors. Green, light green, and dark green. This should be totally different, but dark green's fat down here. lots of fat, breathing frequency. So now I can track his breathing, and this will be one of the markers on the test. We're also doing a breath analysis, how efficient you are at breathing. So this seems pretty high. If they're in zone 2 to zone 3, zone 4, zone 5, their breathing frequency might be more 40 and higher. So we're tracking that. Okay, so back to definitions. Breathing frequencies and fuel sources. As I just showed you, breathing and ventilation rate increases as exercise intensity rises because we need to exhale faster, get more out so we can bring in more oxygen, meet the demand of the exercise at hand. The fuel source also shifts from fat to carbohydrate as exercise intensity increases. And this will show the ratio. I've talked about the RER, RQ value. 0.7 is that 100% fat versus 1.0 is 100% carbohydrate. So let's go back to our raw data for this example, and you can see the fat, carbs changing. And if we want to look at that RER score, go to that top one where I can change, you can see RER is going to be showing here. And then let's take out some of the other markers. And let's look at that. So now we're looking at RER is respiratory exchange ratio. Remember, the lower the RER, 0.81, the more fat they're burning. 0.85 is about 50-50. And then we can see where they're burning 1.0 or higher. That's all carbohydrates. So red about there. And you can see the breathing frequency, and which seems odd. So this should be higher than this. The breathing frequency, you might have been losing some air. But if this was all perfect, the heart rate here, 170, that is about 170 when he starts to go more 1.0 and higher RQ. Okay, that's your definition. You can see the shift in the RER, the fuel source uses, fat versus carbohydrate changes. So we're looking at how low intensity is your zone 1 and 2, where we're looking at RER 0.7. That's going to be the more fat, right? So you got that. Now, the ventilation, VE, increases with exercise intensity, but remains low in zone 1, 2, and the demand for oxygen met without really changing ventilation. Then we talked about transitioning from low to moderate intensity, and there we're looking for that VT1. So we're looking at the shift from primarily fat to a combination of the fat and carbs. 0.85 is RER for that. The breathing frequency, we're looking now at beginning to increase more of a noticeable shift in the ventilation rate, VE, to accommodate the increased production of carbon dioxide. Again, I would not go by buffering of lactate, but just buffering of lactate as a fuel source. And it gets recycled. Start to use more carbs. So you'll see the RER go 0.85 to 0.9. And then the VE, we're paying attention to that breathing frequency. Ventilation increases more rapidly as the body requires more oxygen to expel carbon dioxide. Now we get to moderate intensity around VT1 to VT2. So this is more zone 3 as we transition into zone 4, and then higher intensity is going to be getting beyond VT1 to VT2, and that's going to be your zone 5. So you can take a look at all those notes. Now we go back to what does that mean when we're doing the VO2 peak or max? RER is 1.0 or higher. Shallow breathing pattern, and this way we want to do some of that breath work. Now, assessment of VT1 and VT2, what do you do with this information? So we're collecting the VE and the VT1, VT2, and we're looking at the RER. So a lot of initials and words that might not make any sense to you. So a lot of people would get this metabolism test done, and they don't get someone to explain what to do with the data. We want to identify your unique self. Where are your areas of opportunity? What have you been doing in your training program? What are you working towards? So what are your goals? And then what's working, what's not working? Let's look at where you can see we need a little more time in. Maybe your zone 2 is not as big as it should be if you're an endurance athlete. Maybe as an aging athlete, you struggle at the higher intensity, so we may need to do more correct interval training. Remember this chart going down to zone interval training would be that short 8 to 10 sets, 10 to 30 seconds, zone 5. But remember, I've said this 1,000 times, recovery duration is 20, 60 seconds because it's a work to rest ratio 1 to 2. Your zone 1, that you're in zone 1, actually in your zone, say 120 heart rate's your zone 1. You hit 120, start your timer. You need to be there 20 seconds to 60 seconds before you go do your next sprint. So that's on there. Now, what do you do with this information? I said, figure out your fueling plan. Maybe we need to adjust your strength training routine. Maybe we need to adjust your protein intake, strategic carbohydrates, as I just had some frozen blueberries are my new favorite discovery before a workout that's higher intensity. So we want to improve. I wrote it. What do we want to see? What do we do with this data? That's same with the Oura Ring, Whoop. I think people they collect data because it's trendy, but they don't know what the heck to do with it. So identifying where you are. Let's get baseline data. Okay, great. We just tested today. We've got all this information. Now let's retest in 3 months. I think 6 months is too long because it will change. You can see changes 2 to 3 months. Get retested because your zones will change and your goals will change based on what we identify when we do our assessment. Now, maybe you need to do the high intensity. So training above VT2, you'll hear about the 4x4 VO2 max workouts or the 10 by 1 minute. It's training at that level. So remember, we want to identify what those heart zones are for you. Zone 1 is just as important as knowing your zone 4. Zone 5, you just go all out, but make sure you know what your zone 1 is so you can come down low enough. Threshold training near around that VT2 and just increasing the volume. It says here, spent various intensities, increase your VO2. So I think, that varies. Again, this is just suggestions I pulled up, but it's more looking at female versus male as I got down to here. And what are your goals? Now, if we're training for endurance event, we want to really get that large engine in zone 2. I want to be burning fat at higher levels. So if my fat burning peak is 140 right now, I want to see that. Can I get it to 150? How hard can I work? How fast can I go where I'm burning primarily fat? So knowing you'll get faster and faster as the Method method, max aerobic function, we can correlate that with our true zone 2 that we test and identify what that zone 2 is for you. Okay, because that's where we want to stay and build up, get faster and faster at that max aerobic function heart rate or your zone 2 for our racing and endurance events, right? So as you're aging, just improving your metabolic health, you may just do this workout in zone 2 once a week. But if you're training for a race that's requiring you to go 2 hours or more, you might want to spend more time in here and work on getting faster by doing the combination of zone 2 and the right type of speed work for you correctly. Most people don't do speed work right. They're in zone 3. They're not doing intervals. Now, how does mitochondria play a role here? Mitochondria density, we want to look at how can I get more mitochondria? How can I get rid of the dead cells? That's what we're looking at. Mitochondria are responsible for oxidizing fats to produce energy. So when we hear about mitochondria health, when we hear about chronic fatigue, cell danger response, we really want to identify how healthy are mitochondria. Am I struggling with energy in my workouts? Well, maybe we need to work on mitochondria health, looking at supplements is great, but how are you training? How are you eating? How are you recovering? We want to look at the whole athlete, whole individual. You don't even have to be an athlete, but by increasing mitochondria efficiency and density, athletes can help their ability to burn fat, athletes of any level, even at higher intensities. As I said before, this was myself when I was racing. I was great at long distance because I trained that aerobic engine, my zone 2. I could go very fast and burn mostly fat. Right. So mitochondrial function helps clearance of lactate, help produce high intensity efforts, delay onset of fatigue. Again, we'll go into what lactate research is saying now. And using that data to figure out, is my VO2 getting better? Is my zone 2 improving? Do I want to look at what speed am I reaching that metabolic crossover point in zone 2? What speed am I working on when I'm trying to hit my higher numbers as say 160, 170, if that's your high end? So you can see improvements that way. Nutrition, your macronutrients, really working on recovery, mitochondria health, overall performance, working on training cycles and more. All right, so lastly, then I got to go to the gym. I'm working out at my mom's clubhouse where I can't go until noon. So I'm just doing this before I go. Now, lactate and fatigue. The old view is that to cause muscle fatigue and acidosis during intense exercise. We thought that lactic acid, accumulation of lactate in your blood created acidosis, gave you that burn, lactic acid burn and fatigue. That's been overruled. Lactate is now recognized as a fuel source. During our high intensity exercise, lactate is produced in the muscle cells as a byproduct of anaerobic glycolysis. Instead of causing fatigue, lactate can be shuttled. So we're more focused on lactate shuttling. It can be shuttled to other tissues as a heart and slow twitch muscle fibers. So slow twitch muscle fibers are your zone 2 endurance. Fast twitch is your sprint ones, where it can be converted back to pyruvate and then used through the Krebs cycle to produce more energy via mitochondria. So we're looking at lactate shuttle. We're not talking lactate acid. Now, what causes the acidosis are the hydrogen ions. And listen to my podcast with Daniel Crumbach. We did 3 episodes. One was on Instagram. So check out Coach Debbie Potts on Instagram. And then I did, Joe Friel did a great one as well on my podcast. Hydrogen ions are associated with acidosis during intense exercise, were not produced by lactate itself, but released during ATP hydrolysis and other metabolic processes. When lactate and hydrogen are produced together, they're not bound in a manner that lactate directly causes acidosis. So it's the hydrogen ions that are creating acidosis, is how I understand it. You know, that makes me wonder, I have to look this, another rabbit hole. I'm drinking my hydrogen water here. How is that related to hydrogen ions? If I shouldn't have hydrogen water, another rabbit hole to understand. Lactate clearance, mitochondrial function, improve mitochondrial density and efficiency, increase the capacity to oxidase lactate. During moderate intensity, well-trained individuals with greater mitochondrial capacity is what we're looking for, can utilize lactate more effectively, and this results in delaying onset of fatigue and maintaining performance. I want to work on improving mitochondrial function. Part of that was my ability to improve oxidizing lactate for fuel. And going back to this word, we should work on lactate shuttling. All right, the body is various body buffering system, bicarbonate, proteins, phosphates all help manage changes in our pH. When these buffers are overwhelmed, they produce H plus hydrogen. Acidosis can contribute to muscle fatigue. Now, what do we do with this? Improve your lactate shuttling, not just lactic acid, but your ability to clear and use lactate. Enhancing mitochondrial function and the efficiency of lactate shuttling. So understanding that lactate is not the direct cause of fatigue, that allowing athletes to focus. Nowadays, we're looking at improving lactate clearance utilization, optimize training intensity, volume recovery to help mitochondrial health, metabolic efficiency. So we not want to say lactic acid. It's not used as waste product, but an energy metabolism. New research has been out a long time, but we keep hearing this lactic acid. Misconceptions about lactate fatigue have been clarified. Lots of research. looking at the role of mitochondria, energy production using lactate through pyruvate in the Krebs cycle, the regulation of acidosis during exercise. So then we'll go into another time. Okay, what does this mean for male versus female rabbit hole, changes as we age, and more on how we can use this data. So check out the rest of this blog, Zone 2 training, VO2 max training, HIIT training, trying to get more data on women versus men, and as our hormones change for women, how we want to look at options. So yes, I did this on ChatGPT, but you need to look at the right, ask the right questions, and I have to make sure I'm saying the same thing because it told me there's lactic acid burn, and I had to reword and pull up research about the new thresholds, so then you get the right data. All right, hopefully that helps. I'm going to go work out and do some strength training and mobility because it's 115 degrees where I am in Palm Desert today. So enjoy your day and we'll chat soon.